that works. Some of you haven't and are like, I'm not sure if I know the speed formula or the distance formula or how to write it, okay? Technically, the formula is really easy to remember because you have dealt with speeds before. I'm sure every one of you has been in a vehicle, and that vehicle has traveled at a certain speed.
What did you say?
So this is the last question on 7.4, and it is on page 565. So if you were in a car, and yet I said, how fast were you going on the highway? You'd probably say, oh, we were going 100 kilometers per hour. So you've already have the formula in your vocabulary, because speed is measured in kilometers per hour. So speed is distance over time. And then I don't know, sometimes teachers show the triangle formula of this. Have you ever seen the triangle formula of this, where they make a triangle and they have distance up here, speed down here, and time there. And if you want to find any version of the formula, you just cover up, there we go. If I cover up, oh my goodness. If I cover up speed, I have distance over time. If I cover up distance, I have speed times time. And if I cover up time, I have distance divided by speed. So the triangle lets you find each formula very quickly. Of course, if you have one formula, you can just use your mathematics to rearrange it to find all the other formulas. Like if I wanted to take my speed formula and multiply both sides by time, then I would get distance by itself, and I would get my distance formula. So this is just the distance, speed, time formulas, how to use them, where they come from. A lot of people really like that triangle because it's very quick to be able to write any formula. So that's our background. And now we look at our question, and it says, on a Canoe trip, how do you say that, Nate? Patton? Or does it rhyme with Satan? Peyton? Maybe. I don't know. Okay. The question just got very dark very quickly there. Okay, we'll go Patton. We'll keep it safe. Paddled upstream a distance of 10 kilometers, and then on the return trip, traveled downspeed. The average speed of the canoe was 5 kilometers per hour greater when going downstream. Makes sense. Than when going upstream. Okay? Write, then simplify an expression for Patin's total paddling time in terms of the average speed upstream. So what we have, and what we can sort of do here, is we can make a chart to understand what's happening. In this chart, we're going upstream, and we're going downstream. And as far as distance, speed, and time goes, we're going to look at what we know. Do we know how far Patton traveled upstream? Yes. 10 kilometers. Do we know how far he traveled downstream? Yes. He returned the same one, so 10 kilometers. Do we know Patton's speed? No. So we're going to have to put that as x. But if his speed was x upstream, and it's 5 kilometers per hour faster downstream, does it make sense that this would be x plus 5? And then for the time, does it tell us the time? No. But if we look at our triangle, time is always distance over speed. So we could write the time for upstream to be 10 over x, and the time for downstream to be 10 over x plus 5. So we are using this formula that time is distance over speed. We created one thing that we didn't know, and that was the only variable we used in the whole chart. So this is going to be part of the strategy as well. Once we decide on the one thing that we don't know, or in this case, the question tells us that we want to write it in terms of the average speed upstream, that's our x. That's the one thing that we don't know, and we want to relate everything else to it. So knowing that this is x told me the downstream speed was 5 more, x plus 5. Knowing that it was x lets me figure out my time, because time is distance over speed. Okay, our chart is just holding our data. But now that we're holding our data, we can answer this question. We want an expression for the total time. Does it make sense that the total time would equal this time plus this time? And what are we doing? We're adding fractions. How do we add fractions? We need a common denominator. Do we have a common denominator? No. This one has an x. This would get grouped together as an x plus 5. And so what we could do, of course, is get that common denominator. I would have to multiply top and bottom of this one by x plus 5. I need to multiply top and bottom of this one by x. And this gives me a common denominator of x times x plus 5. I'll leave it factored. On the top, I can multiply things out. I'm going to get 10x plus 50 plus another 10x. So simplifying this will be 20x plus 50. I could factor a 10 out of the top, but I would notice that even if I did that, the factors wouldn't be identical. Nothing would simplify. So this will be our final simplified answer. Okay? What's going to happen in the last section of this unit is you're going to get this same question, but instead they're going to say the whole trip took him 2 hours. How fast was he paddling upstream? So now we created the equation for the total time, and it will just be, now it's equal to 2. And if it was equal to 2, we can now solve it. So this is a setup for later. I'll get you to circle question number 11, but we're not going to do that right now.